Okay, so for day 2, we are solving these absolute value inequalities using algebra. Okay, so this is our day 2. So we're going to be using different algebraic methods here. And just like yesterday, you have 2 different cases. Okay, so there are 2 cases that you have to consider. Okay, and the reason why you're considering 2 cases is because when you have the absolute value of something, okay, if I have the absolute value of some variable and that's equal to 3, right, what could our 2 values of A be? What could our 2 values of A be? 3 and -3. Okay, so that's why we have to have the 2 cases. Okay, now we're going to deal with things that are more complex than just A. So we're going to set up 2 inequalities, and we're going to investigate how to rewrite them as a compound inequality. Okay, so we're going to investigate the 2 cases for the absolute value. So if you have some algebraic expression, I know a lot of times we do mx plus b. Another thing you might see is ax plus b. Okay, we're going to investigate what happens if it is less than c. That's going to be our first case. And then over here, we're going to investigate when we have a greater than c. Okay, so based on what we did yesterday when we're separating our cases, we know that whatever is inside can either be positive, which would mean ax plus b is less than c, or like we were just talking about, whatever's inside could be negative. So you can think of it like this. Could be negative ax plus b. It just has to be that whole quantity, and that would be less than c. Okay, so we don't know what case we have. We either have the inside that's positive or the inside that's negative. Well, this, we don't have to go any further. We have ax plus b is less than c. For this, we're going to divide by -1. And when you divide by a negative, remember it flips the sign. And c divided by -1 is going to be -c. Okay, so we have to determine, could this happen at the same time? Okay, so this says the quantity is less than c. So could I have something that is less than 3 and then greater than -3? And if I can, let's take some numbers. Are there numbers that are less than 3 but greater than -3? 2. Good. What else? 1. Okay, so these can happen at the same time. Because they can happen at the same time, we join them using an and process, but we're not going to write and, okay? It makes one big inequality. Okay, so if they can happen at the same time, it's an and situation. And what we do is we put the ax plus b in the middle. And we say that value can be less than positive c, but greater than -c. Okay, so this is what happens when you have the less than. Okay, now we're going to set up b in a very similar way, except this time we have a different symbol. So our case 1 is still whatever is inside there could be positive. And case 2 is whatever is inside could be negative. Okay, so following the same property that we did before, we're going to solve. You switch when you have a negative. Okay, so this is saying some quantity is greater than C. So some value, again, I think it's helpful to think of it as a number. So can some value be greater than 3, but then also less than negative 3? Is there any number that is greater than 3, but also less than negative 3? No. So that cannot happen at the same time. Because it cannot happen at the same time, we connect it with an OR. And the compound inequality are going to be two different inequalities. So it's AX plus B is greater than C, or AX plus B is less than the opposite of C. This is going to happen anytime you have a greater than. Okay, so with your and or cases, okay, know that the and is one inequality, because they occur at the same time. And then or is going to be two inequalities. Because they can't happen at the same time. Okay, so and is one inequality, they occur at the same time. You can have a number that is both less than 3 and greater than negative 3. But or two inequalities, because you can't have a value that's greater than a number, but then also less than the opposite of that number. Okay, so what we're going to do is we're going to organize our findings into a table. So we just did the less than and greater than. This is also going to apply when they are equal to. So the absolute value inequality is going to be what you are given. Okay, so this is going to be what's given to you in a problem. The compound inequality is what you are going to write. It is an equivalent expression. Okay, so we can do the less than and the less than equal to. Okay, so when you have a problem, you want to isolate the absolute value. Once you get the absolute value isolated, you have a less than or less than equal to. Okay, then you can rewrite as the compound inequality. Okay, so these are your cases. So it would be the opposite of C is less than AX plus B. That is less than C. The opposite of C is less than or equal to AX plus B. And that is less than or equal to C. So you can use this table as you're doing your homework just to double check to make sure you have the right setup. And then the more you practice, the more you'll find yourself not even looking back at the table. And then you have the greater than and the greater than equal to. Okay, so the less than. No, I'm recording. My Okay, we'll do that. Yep, bye. Okay, and then, so for your greater than, you have AX plus B is greater than C. Okay, and then this is when you have the or. So you either are going to write AX plus B is greater than C, or AX plus B is less than the opposite. Okay, so it's always greater than or greater than equal to the original, or you do the flip and you do the opposite. Okay, so our first example, it says to solve each inequality, graph the solution set on a number line. So the first thing I want you to do is I want you to isolate this variable, okay, or isolate the absolute value, not the variable, okay, isolate the absolute value, so think about what you have to move over, and then see if you can find the equivalent inequality. So when you're isolating the absolute value, you have to move anything over that's outside of it. So what's on the outside that we have to move over? Yeah, so we have to move over the 2, so we're going to subtract it from both sides. Okay, and then once you do that, now we're using our chart. So if you have the absolute value is less than or equal to, okay, that's what we have in the first part of our chart here. So we are going to write the equivalent form. So your first step is always to isolate the absolute value. So yesterday when we were solving equations, right, we had to move things over to get the absolute value by itself. And then once you have the absolute value by itself, you are going to write the compound inequality is what it's called. Okay, and that's what you can use your chart for. So if it is less than, that is where you have the 1 inequality. So it can be less than or equal to 7 and also greater than or equal to -7. And then if you guys remember how to solve the compound inequalities, whatever you do to all 3 sides. So we would subtract 5 from the right, from the left, from the middle. Okay, and again, this is a no calculator section, so we want to exercise those mental math muscles. Okay, so we're going to get m by itself. Anything divided by itself is what? 1. Negative divided by positive, make sure you keep it negative. Okay, and then you can just box in that as your answer. You have -6 to 1. Okay, so then you have a closed circle at -6. You have a closed circle at 1. What this means is the value is somewhere in between these two. So your number line or your graph on the number line does not have an arrow on it. Okay, it's not going in one direction. Okay, it looks just like a barbell here. You have the bar and then your weights on each side. That's what it looks like. Okay, anytime you have an and graph, it should look like this. Okay, if it doesn't look like this, then Houston, we have a problem. Okay, so based on what we did for part A, can you guys do the first couple steps of part B? Okay, so you're going to isolate your variable. All right, so after you subtract 8 from both sides to isolate the variable, you have the absolute value of 6x plus 15. And you can make those a little bolder, just it is so easy to confuse those for one, so sometimes I try to do that so I don't confuse myself. And then because it's greater than equal to, what you would have set up is you would have the 6x plus 15 is less than or equal to negative 1. And then on this side, you'd have the opposite. What's the opposite of negative 1? 1. Okay? Now, some of you might notice there's an issue here. It's saying that this value is greater than or equal to 1, and at the same time, it's less than or equal to negative 1. Can that happen? No. And if you were to solve it, because you might not remember that right away, I'm just going to put a star. Okay. So value can't be both greater than 1 and less than negative 1, which is what this is saying. Okay, so if that happens, then you can just write that, and then you can write no solution. Okay, so for here, it's going to be no solution, or you can write the null set. Okay, so if that happens, that is a special case. Okay, I'm going to show you another way that you can notice that, because you might just be in the groove and solving things, subtracting things here. You have 6x, negative 16, negative 14. You're dividing by 6. You're reducing like a rock star. Dividing by 2, dividing by 2. Okay, and then you get here. So this is another situation where what is bigger, negative 7/3 or negative 8/3? Which one's closer to 0? Yeah, so if you have a value, and sometimes it's easier for people to picture this as decimals, this is the bigger value. You can't have those. If it can't happen at the same time, okay, then there is no solution. You don't have to graph in this case, okay, because what happens with the graph is you end up getting a graph. Well, really, this would have to be negative 8/3, and this would be negative 7/3. You end up with a graph that has this gap in it, and this can't happen in an and situation. Okay, so no gaps. If you have a less than or equal to situation or less than, okay, you can't have that. Okay, so if you get one of those on your homework, you may realize it here. You can just say it can't be both. There's no solution. If you go a little further, it's okay. You don't have to. Okay. Now, you can have gaps in your graph if it's or. Okay. You just can't have it for the and situations, which are the less than. Okay, so then for part C, we have the absolute value is greater than 0.5a plus 4. This is isolated already. There's nothing that's added or subtracted to it. So we can go ahead and write our equivalent values. Okay, so this one is greater than, so I'm just going to use my chart. So for the greater than, I either have this or this. Okay, so I have 5.5a plus 2 is greater than 0.5a plus 4. Okay, so it's going to be exactly what it is, or you have whatever is inside the absolute value, and you flip the sign and do the opposite. You flip the sign and do the opposite of that quantity. Now, again, yesterday we talked about if you have a binomial, if you have two terms, you have to make sure that you distribute. So that's why you'll see me putting parentheses so I don't forget to distribute. And then we're just going to solve each one. Okay? And these turn out pretty nice, because what's 5.5 minus a half? Just 5. Okay, and then you guys go ahead and solve the second one. Again, make sure you distribute to both of those. Okay, and then will you solve for A, please? And then go connect your solutions with an OR. All right, and then you're gonna write your solution with an OR. Good. Okay, so you're moving. Don't wait for me to do this. You guys, I'm giving you time to do it, okay? So this is going to be 6a, and then if you want, you can do this at the same time. So it's going to be 6a is less than negative 6. Okay, and then do I have to switch the sign here or no? No, only when you're dividing by the negative. So if the top is negative, that's okay. So the way that you're going to write your solution is you start with the lower value. So what's lower? The less than. So A is less than negative 1, or A is greater than 2/5. Okay, and then we're going to go down here. Okay, and then again, like I said yesterday, I'm lenient about your number lines. As long as you have your key terms labeled there, that's fine. And then are these open circles or closed circles? Should be open circles, because you have the greater than, no equal to. So you have an open circle at 2/5, and then that goes to the right. Open circle here goes to the left. Now this one you have a gap, that's okay. Okay, anytime you have the or, okay, that has a gap in between. Okay, it's saying all of these values or all of these values. Okay, they do not have to happen at the same time. Okay, so for part D, can you please isolate that absolute value? Alright, so if you're isolating that variable, what are we doing first? We'll do that second. Well, technically you could do it first. Just make sure that you distribute. Yes. Okay, so I would add 13 to both sides and then multiply by 4. That way you don't have to multiply 4 by 13. Okay, and now you're going to multiply by 4. When you're multiplying 4 by 18, I think the simplest way to do that without a calculator is doing 10 times 4, which is 40, 8 times 4, which is 32, and then just add it together. Okay, because if you're in here, then you're good at your math facts. Those are 2 very simple math facts for you to do. And then from there, now you can set up, if it's greater than, you have your 2 cases. The first case is always this. You just don't have the absolute value. And then the second case, I remember it because I say, okay, if it's negative, then I got to flip the sign, right? That's where it comes from. Okay, so we're going to add 12. We're going to divide by 3. And then I think we talked about this in here. I asked you, do you remember how you can tell if it goes in there evenly? You add the digits. Yeah, 8 plus 4 is 12. So if 3 goes into 12, 3 goes into 84 evenly. That may be something where you just want to do on the side. 4th grade style, 3rd grade style, 4th grade. I remember doing long division in 4th grade. So 3 goes into 8 how many times? 2. Subtract 24. Okay, and then 3 goes into 24 8 times. So x is greater than 28. Okay, now how do you guys feel about adding the negatives and positives? Are you pretty confident in your abilities? You can always just subtract, right? What's 72 minus 12? 72 minus 12 is 60, and then because 72 is bigger, you just make it negative. This one's nice and easy for us. So you have x is less than negative 20. Okay, and then again, when you're writing your solution, you just put the less than first. Okay, so it's x is less than negative 20, or x is greater than 28. Okay, and the or means they're not happening at the same time. That is fine. And like I said, as long as you have your key values on there, you don't have to worry about the little tick marks. I know that can be a lot. Okay, and then you should have them going in opposite directions. I'm going to make that a little clearer. It's open. Doesn't look great. Okay, and then again, these were both open because they didn't have the equal to. So it's close if it's equal to, open if there's no equal to. Okay, so you can continue your homework right on yesterday's homework, and then I will check both of those tomorrow.